Hello everyone, this is Ashutosh Raut and this is the fourth video on DP900 exam summary. We have module 4 today. We will cover module 4. Now module 4 is related to data analytics in Azure, where we have data warehousing concepts and data visualization, Power BI, etc. tools. So first of all we have this image over here where we have multiple Azure services like Azure Data Factory. We have for ingestion of data. Then for data store we have Azure Data Lake, Azure Databricks. We have prepare and transform data, and as a model and serve we have Azure Synapse Analytics. So it is important to remember which service is used for what purpose. The next we have is Azure Data Factory. Now Azure Data Factory is an integration service which is used in ETL projects, extract, transform, and load. Azure Data Factory process. This process which Azure Data Factory follows. So first of all, we have like connect to the required data sources, and then ingestion of data happens. So for this, we have Azure Blob Storage, Data Lake, Cosmos DB, Synapse Analytics, and S3. So all these services can be our data sources. The next step is to transform the data in the pipeline, and then publish this data into destination. So mostly in destination we have Azure Data Warehouse, Azure SQL database, Cosmos database, then blob storage, data lake, and Synapse Analytics. Now as a part of Azure Data Factory we have some top level concepts where we can expect some questions. So first is pipeline. So what is pipeline? Pipeline is nothing but logical grouping of activities that performs unit of work. This is typical definition we can say. And the data factory can have one or more pipelines. Then mapping data flow. Now mapping data flow is nothing but which is used to create and manage transformations. Whatever transformations we have as per the business logics, we can create and manage transformation using mapping data flow. Then we have activity. Activity represents processing steps in a pipeline, and dataset it represents data structures within the data store, and it is used to represent named view of the data. Then we have linked services is used to represent the way connections are made to the data sources. And integration runtime, it is compute infrastructure which is used to run the pipelines. And integration runtime provides the bridge between activity and linked services. Important point. So this is about the top level concepts. The next we have is Azure Data Lake. Now Azure Data Lake is nothing but which is used to store raw data. We have like seen earlier Azure Data Lake data store. It is serve purpose of a data store. Now it can be used as a staging area. So like making transformations, before transforming the data, uh, we can store this data, and it can serve a purpose of staging area. Uh, then it is version of a Azure Blob Storage. So it is, we can say, a version of Azure Blob Storage with role based access control and compatibility with Hadoop distributed file system. And this can run Hadoop using Azure HD Insight. So these are additional benefits or additional things that we get with this Azure Data Lake. Next point is Azure Data Lake can be organized into directories and subdirectories. We just need to enable hierarchical namespace on the advanced tab. So it is by default it is not enabled, but if we enable this hierarchical namespace in the advanced tab using Azure console, then we will be able to get organized data into directories and subdirectories. And Azure Data Lake can be used by Data Factory, Databricks, HD Insight, Data Lake Analytics, and Stream Analytics. So the next we have is Azure Databricks. Now Azure Databricks is nothing but implementation of Databricks platform on Azure. Now Databricks is nothing but data analytics solution, which is built on Apache Spark actually, and it provides big data modeling, processing, and streaming. Now Databricks actually makes use of a Spark clusters for processing the data, and it has drivers to import data from databases or data Azure Blob Storage, Data Lake Store, Hadoop Storage, Flat File, Data Warehouse, and streaming data. So we can import data. So it has drivers basically. Then next we have is let me use highlighter. Clusters. Okay, clusters are computation resources and configuration. Now Spark code is created in notebooks inside the cluster. So these clusters have multiple Spark nodes, and notebook contains cells. A notebook has cell, which is a separate block of code, and these cells can read and process the data from multiple data sources and write these results to the data store. And these jobs can run notebooks immediately or when scheduled. So this is nothing but a pipeline that we create. And we have email alerts as well. Email alert can be set up in case of job start or success or failure. Now job create automated job cluster when run and terminated the cluster when complete. So we can basically automate these jobs, and this automated job cluster cannot be restarted. So this is one thing to remember, it cannot be restarted. And other clusters are all purpose clusters, which can be manually terminated and restarted. Multiple users can share all purpose clusters. So there are basically two types: automated job and other clusters. Other clusters can be terminated and restarted, but automated job clusters are not. Then next we have is Azure Data Explorer, or we can call it as Synapse Data Explorer as well. Now it is a data explorer, as the name suggests, and we can explore structured data, semi-structured, and unstructured data. And it is optimized for log analytics. So if in any question you can, if you observe which service is optimized for log analytics, then this is the answer, as you Synapse Data Explorer or Data Explorer. Remember Data Explorer, and it uses Kusto query language. It is important. KQL, I have observed this question. So it uses KQL to investigate telemetry and time series data. Now KQL is important. It can work with massive amount of data, gigabytes and petabytes, integrated between Data Explorer, Apache Spark, and databases. And it is used for analysis of log and event data from on-premises, cloud, or other data sources, and also used for building Internet of Things analysis, software as a service solutions. Okay, so these are the use cases. Sometimes they provide use cases as well, and they can ask which service will be used for this use case. So these are the use cases. Next we have is Azure Synapse Analytics, formerly known as SQL Data Warehouse. So it is data warehouse, as the name suggests. Azure Synapse Analytics is a SQL server, is based on SQL server. So it is based on SQL server with flexibility of Data Lake and Apache Spark. Flexibility means having an ability to integrate with Data Lake and Apache Spark. It is analytics ELT engine, which process huge data quickly. Now we can ingest data from Data Lake or other sources, then transform that data and run complex queries using Azure Synapse Analytics. Now it supports massively parallel processing. This is also important. It supports massively parallel processing, and as a part of massively parallel processing, we have control node which interact with outside applications, then optimize request and control the compute nodes, and when compute nodes are finished, results are sent back to the control nodes. And to query, So okay, we have data, and if you want to query that data, then we can use Azure Portal's query editor, then SSMS, Azure Data Studio, or Visual Studio for querying purpose. And there are two computational methods, models as a part of this Synapse Analytics: SQL pool and Spark pool. And use case for SQL pool is complex reporting, data ingestion via Polybase. And for Spark pools, we have data engineering, data preparation, and machine learning. And these pools can coexist. So this question I have observed one time. So I have added this point at the end, that these pools can coexist or not. So just a point to remember that these pools can coexist. Next is data analysis services. So can be used to build tabular models to support OLAP processing. And as a part of data source for this Azure analysis services, we can have SQL database or Cosmos DB, Synapse Analytics, and data lake store. It includes graphical user interface for connecting data sources and creating queries. So we can connect to multiple data sources, and then we can create queries, and we can use analysis services to explore data, or we can use Power BI for data visualization. Now next is Azure Stream Analytics. Azure Stream Analytics is nothing but real-time stream processing. Now if in any question you see, or anything related to real-time stream processing, then it is definitely related to stream analytics. So this way you can remember the keywords and service name, and it will be definitely helpful. The exam is basically trying to know whether we know that which service is used for what purpose, what is the use of this service, and use cases basically. Now Azure HD Insight. Azure HD Insight is nothing but big data processing service. It is same as Azure Synapse Analytics, but using Spark nodes, Spark clusters, Apache Kafka, Hadoop processing model. It is nothing but Hadoop infrastructure, we can say. Now as a part of Hadoop infrastructure, we have Spark. Now Spark, what the Spark does, it splits data into smaller parallel tasks basically. When the we have huge data to analyze or process, then our traditional systems cannot process this huge data, and then we need to use big data technologies like Spark or Hadoop. Now we have Hive. Hive is SQL dialect uh, to use HD Insight cluster running massively parallel processing queries. And then Hadoop. So Hadoop is nothing but distributed system which uses MapReduce jobs to process large volumes of data efficiently across multiple clusters. So there will be multiple clusters known as nodes, and MapReduce jobs. So these jobs can be used to process huge amount of data. So these jobs can be written in Java and in Python as well, or abstracted by interfaces such as Apache Hive. And then we have HBase. Now HBase is nothing but NoSQL data storage and querying. So I have highlighted keywords here, so just remember the keywords. Now for Apache Kafka, we have ingesting streaming data. And Storm is real-time data processing through topology of spouts and bolts. Now it stores data using Azure Data Lake Storage, Azure HD Insight. Azure HD Insight stores data using Azure Data Lake Storage, and it can be used or instead of Azure Synapse Analytics. So we can use with Azure Synapse Analytics as well, or we can use Azure HD Insight alone. Next we have data visualizations. This is also very important. So as a part of Azure data visualization, we have Power BI desktop, Power BI service, and Power BI phone app and web browser. The next we have is Power BI desktop, which is used to connect to data and create reports and visualizations. Then Power BI service is used to create basic reports and dashboards. The main function is to create workspace for sharing reports and dashboards. And Power BI mobile app, which is used to view and interact with reports. So these services are basically related to data visualization. So that's all we have as a part of module 4. So thank you everyone. I will try to come up with a video including the questions, practice questions for DP900. So please support, please share, like and subscribe. Thank you so much.